In this video, we'll see how to add and subtract numbers in scientific notation. There are a couple of ways to do that. The easiest, before we understand the scientific notation better, is to convert the numbers to standard form, add or subtract, and then convert the answer back to scientific. Let's see what that can look like. So I have a number in scientific notation plus a number in scientific notation. To understand those numbers, it's always best to convert to standard. Like 2.75 times 10 to the third power means 2.75 times 10 times 10 times 10, which represent a number in thousands place. So 2 times 10 to the third power is 1,000, so 2,000. 2,075 with a 0, so it's 2,750. Moving the decimal to the right 3 times, so 2,000 and then 750. 1, 2, 3. That would be an extra 0 needed. So if I was to convert to standard, that would be 2,750 plus 9.2 times 10 to the second power is 100. That's times 10 times 10. So that will be 900. 910. We can see that 9.1 times 10 times 10 is 910. On paper, you would move the decimal twice to the right, so add a 0. That would be 910. So in scientific notation, we can convert to standard, then add. So I have 2,750 to add with 910. That will be 3,660 in standard form. And I have to convert that back to scientific. That will be 3,000, so it's 3.10 to the third power. Because it's 3,000, means 3 times 1,000, which is 10 to the third power. The decimal is after the first significant digit, and we have 6 behind. The last 0 we don't need to write. Then becomes our final answer in proper scientific notation, 3.66 times 10 to the third power. Let's see another example. 4.3 times 10 to the second, it is 400, because 4 times 100 is 430. And then 5.1 times 10 to the fourth is by multiplying 5 times 10 times 10 times 10 times 10, 4 times. So on paper, we can use moving the decimal twice to the right for multiplying. I need an extra 0 there, so it will be 430. Plus 5 point, and then move the decimal 4 times to the right. 1, 2, 3, 4. So I'm going to need 3 more zeros. That will be 51,000. When we add, so I'm going to add 51,000 with 430. That will be 51,430. In scientific notation, we need to place the decimal after the first significant digit 5. Then we need to multiply it by a power of 10 to the fourth, which represents the 10,000. And behind the decimal, we have 1, 4, and 3. So 5.143 times 10 to the fourth power. Let's see another example. Subtraction of 2 numbers in scientific notation. We have 5.44 and then times 10 to the fourth power. Again, it's 5 multiplied by 10,000. So that will be 54,400. To see that on the calculator, we can say 5.44 and then times 10 times 10 times 10 times 10. And that's how the decimal moved. On paper, you can move 1, 2, 3, 4 times to the right, so you need 2 more zeros. Subtract 1.2 times 10 to the third power. It's like 1 multiplied by 1,000, so it should be 1,000. 1,200. Or by multiplying, we move the decimal to the right 3 times. Those are the 2 zeros that you need. Then we subtract. In problem we have subtraction, so 54,400 minus 1,200 gives us 53,200, which is 5 point. That is the decimal going after the first significant digit. 53,000 or is power of 10 to the fourth power, and then 3 and 2 behind the decimal, so 5.32, 5 representing the 50,000 times the power of 10 is 4, and the decimal has only the 3 and the 2. The last 2 zeros are not needed to write. Another subtraction problem with the negative exponents. The same procedure. I'll use the conversion to standard. I'll do the subtraction in this situation and then convert back to scientific. So I have negative power, that means division by 10 4 times. So if I use 6.6 and then I divide by 10 and then I divide by 10 and then I divide, so as you come, the decimal is moving to the left by 10 and divide by 10. And that will be my number in standard form. I can show that on paper by moving the decimal to the left this time 4 times. 1, 2, 3, 4. So I'm going to have 3 zeros in front. 1, 2, 3, and then the 6 and the 6. And subtract. Same idea here. 3.8 divided by 10 4 times. Moves the decimal to the left 4 times. 1, 2, 3, 4. There'll be 3 zeros in front. 0.00038. When you subtract, you must line up the decimal. So when I subtract, I have 0.00066, and then line up the decimal. 0.00038. In the answer, the decimal will be lined up as well. 62000. So we have 1,230 zeros and 26. That is going to be in scientific notation a power of 10 negative, because we have a small value, so the significant digit 2, place the decimal. 6 times the power of 10, representing the fourth place behind. 1, 2, 3, 4 behind the decimal. 1, 2, 3, 4. Tens, hundreds, thousands, 10,000 place. So that is the negative 4. Scientific notation. Let's see another example. The negative 2 is the power of 10, so 3.4 divided by 10 2 times. Or move the decimal 2 times to the left. That will be 0.034. Changing to standard, 1.75 is division by 10 3 times, or moving the decimal to the left 3 times. So I have 1, 2, 3. That will be 2 zeros behind the decimal. And then 1 is in our thousands place. So the negative 3 gives you the place value, 10 thousands, tens, hundreds, thousands. So that is the place value represented by the negative exponent. Then the 7 and the 5. When we subtract, we must line up the decimal. So I have 0.034, and then line up the decimal, 001. And then I have the 7 and the 5. So when we have our decimals lined up in order to have the subtraction, tens place, hundreds place. So we have 3 in the hundreds place. That means this is a large number. So if I add zeros behind, that is the same value. I'm adding those zeros in order to have the subtraction. And then we use our rules to subtract. The decimal in the answer is lined up as well. So our answer, 0.03225, in scientific notation will be 3 point, the decimal placed after the first significant digit. Then we have 3 is in the hundreds place, tens, hundreds. Hundreds place is the second digit behind the decimal, so that will be a power of 10 negative 2. So 3 is in the hundreds place. That is your starting point. After that, we have the remaining digits behind the decimal, 2, 2, and 5. One more example. 1.065, we divide by 10 two times, or move the decimal to the left twice, 1, 2. There will be 0.01065. When we subtract, 1.05 multiplied by 10 to the negative 2, so that means that we're moving the decimal again twice to the left, 0.0105. When we subtract, we must line up the decimal, so we have 0.01065, line up the decimal, 0.105, and then add a 0 just to have the columns lined up. And we subtract 5 minus 0, and the decimal is lined up, 5100, because we subtracted. That would be our answer in standard form, but then we have to make sure we convert back to scientific, and that would be 1 point. That is where the decimal goes after the significant digit. Tens, hundreds, thousands, 10,000s, that is the 4th place in the hundreds, so division, which is negative exponent, and then 0.5 behind the decimal. So the scientific notation is 1.5 times 10 to the negative 4th.